Hi guys, welcome back. Let's solve binomial coefficient problem using DP. Write a program which returns binomial coefficient for a given n comma k. So when this is the Pascal's triangle and the binomial coefficient tree follows the Pascal triangle property. So Pascal triangle is whenever you add this to get this cell, you just add the above two cells, and for this you just add these two cells, and for this you add this two, and the right side of any side will always be 1. The extreme right and extreme left will always be 1 in this triangle. So for this cell you just add these two cells above up. Okay, and this represents a plus b to the power of 1, and this represents a plus b to the power of 2, which is nothing but a square plus 2ab plus b square, and this is the 0th coefficient, this is first coefficient, and this is second coefficient, and this line represents a plus b to the power of 3. Okay, this represents 0th coefficient, first coefficient, second coefficient, and third coefficient, like that. Okay, and this represents a plus b to the power of 6. Okay, so when n is equal to 6 and k is equal to 2, 0, 1, 2, what is the coefficient? That is the question basically. So here when n is equal to 6 and k is equal to 2, answer is 15. The 15 is obtained from 5 plus 10. Okay, so when binomial coefficient of n comma k is nothing but n minus 1 comma k minus 1 plus n minus 1 comma k. Okay, 6 comma 2 coefficient is nothing but 5 comma 1 plus 5 comma 2. So this is the recursive function. Okay, so let's write a binomial coefficient. Okay, for example, n can be from 1 to 50. Okay, I am defining n can be from 1 to 50. So I can give any n between 1 to 50. So for 50, a plus b to the power of 50, it can have a very huge value which cannot be fitted in the int. So I am just defining type def long int as lii. Okay, something like this. Okay, so lii binomial coefficient of int n comma int k. Okay, so option 1, what is the option 1? LIA. Option 1 is binomial coefficient of n comma k is n minus 1 comma k minus 1. Okay, and LIA. Option 2 is binomial coefficient of n minus 1 comma k. Right? For binomial coefficient of 6 comma 2, how you will write? Binomial coefficient of 6 comma 2 is 5 comma 1 plus 5 comma 2. Right? So n minus 1 comma k minus 1 plus n minus 1 comma k. So you just return these two options as sum. Okay, option 2. Now the base condition, if k is equal to 0, okay, this part, whenever the k is 0, this is the 0th coefficient, 0, 1, 2, 3. Okay, this is for a plus b whole power 3. So when k is equal to 0, answer is 1. When k is equal to n, answer is 1. That you also have to mention. Okay, n is equal to k, return 1. Okay, so now C out, I am pretty much comfortable with C++. C out is nothing but just like printf, you just add two arrows and write whatever you want. Okay, binomial coefficient of 6 comma 2. Okay, and arrows, it will again print. Okay, is okay. If you are not comfortable with this, you can just switch over to printf. Okay, 6 comma 2. Okay, so this gives binomial coefficient of 6 comma 2. Let's debug and find the answer. So binomial coefficient of 6 comma 2 is 15. Okay, if you just give a space. Now let me give a binomial coefficient of 40 comma 14. Binomial coefficient of 40 comma 14. So as we already know, whenever we keep increasing the n value, it will take exponential time to deliver the results, right? Because of overlapping sub problems, it keeps on solving the same thing again and again. We didn't get the answer yet. So the technique to solve this issue, we have to use a caching technique. Okay, so LII cache. Okay, n will be from 1 to 50 only, so let's take 51 of 51. Okay, so now set up the cache. Void init cache. Okay, we are setting up the cache for int I is equal to 0, I less than 51, I plus plus. For int j is equal to 0, j less than 51, j plus plus. Cache of I of j is equal to -1. Okay, let's call this init cache here. Now store the value for any n comma k. You just store the value into the cache. You store the state for any n comma k state. You are finding the solution, option 1 plus option 2. Before returning, you just store them into the cache. Okay, again if it asks for that particular n comma k, if cache of n comma k is not equal to -1, instead of recalculating again, you just return it from the cache. Okay, now try to debug. You will get the answer immediately. Okay, so binomial coefficient of 40 comma 14 is this one, and if you see the cache, it will try to calculate. You can see the Pascal triangle. So for 40 comma 14, it keeps on calculating what all the present in this. Okay, this is just nothing but a Pascal triangle. Okay, as you increase the n, you have to set up a cache, which is smart recursion. Okay, did we follow these rules now then? So we are a creator. We evaluated the choices. There are two choices left, n minus 1 comma k minus 1 and n minus 1 comma k, and we have written the recursive function with base cases. Yes, and in the recursive function only the varying parameters are kept. Yes, and we set up the cache, and the cache results are, and we capture the results into the cache. And last one, if result is in the cache, we are done, we are returning. Okay, these steps are followed. Fine. Okay, then see you. Let's meet you in the next video with another DP problem.